Hello, let's continue our Sudoku adventure with Dorm Rooms by ChinStrap. So, we do have outside clues here, which are not part of the Sudoku, but inside this bold square, right, our normal Sudoku square, we do have standard 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. But anywhere that we have these sort of gray cells here outside the grid, also just anywhere there's a clue, anywhere there's a blue line, we must fill those with a digit, but we are not restricted by Sudoku rules in any way for what digits they could be. They could all be the same digit, for example, or we could do like 5, 5, and 4, and I don't know why that's highlighting wrong, but anyway. Cool. If it does highlight wrong, it's not actually wrong. It might just be a conflict checker issue, but anyway, we'll see. Now, what are the clues outside the grid? Well, they're numbered room clues. So let's say this was a 4. What that's telling us is that we have to place a 4 somewhere. Obviously, there is a 4 somewhere in this row. And this digit here tells us where that 4 is. So let's say this was a 3. Then we would count 1, 2, 3, and that would put a 4 right there. So because it's 3 away. If this was a 2, that would put a 4 here. If this was a 5, it would put a 4 there. If this was a 3 instead of a 4, it means it puts the 3 there, right? So this is the digit that's being placed, and this is where it goes. All right, so that is numbered rooms. It also works for columns. If this was a 3 with a 2, then that puts the 3 there, because that's telling you, this tells you what the digit is, this tells you where it is. If this was a 5, it would put the 3 all the way down there. All right. The blue lines are region sum lines. So the way you interpret these region sum lines, especially because they go outside the grid, the rigorous thing here is within a line, whenever it crosses a box border, so like here, here, and here, right? It creates a new segment. So this is a segment, we cross a box border, it creates a new segment, we cross a box border again, it creates a new segment. So every segment adds to the same thing. So if this was, say, 2, 3, this could be 1, 4, and this could also be 2, 3. Maybe 3, 2. Anyway, so we're ignoring the numbered room for a second here. But what this tells us is that, this sums to 5, this sums to 5, this sums to 5. That's my point. They would all sum to the same amount. One thing that would be interesting is like if this was 1, 5, that it sums to 6, this could be 2, 4, summing to 6, and this could be 3, 3, because it's numbered rooms. It's outside the grid, so it could repeat. Still don't know why that's saying it's wrong. Anyway, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So this is a gimme in 6x6 at least. What is the minimum 3 cells could add to? Because this is one segment. 1, 2, 3. That's 6. What's the maximum I can put in this cell? Well, that's a 6. So if the minimum here equals the maximum here on another segment, then they have to meet and they have to agree. They have to say, well, that's going to be a 6 then. Oh, this one's interesting as well, because the biggest this can be is a 6, but the smallest this can add to is 6 all once. See, this isn't red. Anyway, so 1 plus 1 6 times is 6. So this is the only way that's going to work. If we try to even increase one of these to 2, suddenly it adds to 7. We can't put 7s in the grid. So we're getting a bunch of digits right away. Now this 6 does place the 1 all the way over here. Did we get anything else out of that? Okay, well, I'm going to fill the 4, 5, 6 here, 4, 5, 6 here, and the 1, 2, 3 here. Whoops. All right, that's not 1, that's not 6, that's not 6. Okay. Do we think about this one or? Okay, we can think about this guy a little bit because we're gonna have some form of low highness going on in this column because they all place a 1. So if you think about it, we're gonna have 1 through 6 here, and that points at every single 1 in the entire puzzle. Now, what we know about 1s is, for example, we can't put a 1 in any of these slots. A 1 in any of these slots would interfere with this one, would repeat a 1 in the box. So the 1 over here is in 1, 2, or 3, meaning this has to be 1, 2, or 3. So we're going to have a low and a high in every pair of digits here, because one of them will place the 1 in the first box, and one of them will place the 1 in the second box. So we have that here already. We have this here. So there's going to be 1 of 1, 2, 3, and 1 of 4, 5, 6. So that's not a huge boon to have discovered because we kind of already have that. Other than this one here, this was maybe helpful. So this sum here is the same as these two, and it maxes out at 5. So these two add to at most 5, meaning they're from 1, 2, 3, 4, I guess, because you can't put 5 or 6 on them. And so they add to anywhere from 3, 4, to add to 3, 4, or 5. These two are the same digit as each other, which means this places the green. Oh, so it can't be a 3 or a 4. Let me make sure that's understood. So whatever, this segment adds the same as this segment adds the same as this segment. So what we conclude is that these are the same digit as each other. Now this is telling us that we need to place this green digit somewhere in this column, and it's going to be whatever's indexed here. But I can't repeat the green in these two cells. It would be 2 greens in this box. And so it can't be 3 or 4, meaning it must be the 2. And then that actually means this is our green 3, 4, 5 as well. So this is not a 2. All right, that's going pretty smoothly. This 3, 4, 5 is telling us that there's a 1 somewhere here, but that's not super helpful. Oh, this is going to add to either 3 or 5. It can't add to 4, so we can remove 4 from all of these. What do we do with that? Let's think for a second. We haven't thought about this line. Maybe we have to think about this line soon. Okay, the first thing I'm noticing is that there's not a 6 on it. So the 6 in this box goes here. That's just Sudoku. But okay, this adds the same as this, adds the same as this. So this is limited. We can put 3, 4, 5 here. So it's either going to add to 4, 5, or 6. This adds to 4, 5, or 6. So what does that mean for this digit? This can't be a 5. So if we're adding to 4, 5, or 6, if this was a 5, we can't put another 1 here. So 1 in the box. So this is minimum 2. So this can't be 5. That would add to 7. So that we can take 5 out of that. If this was a 3, this would have to be a 4, and that would add to 7 as well. So I think this actually has to be a 2. That's our only option, and these are consecutive. Interesting. Yeah, and if this was any bigger, then we blow out our sum. And this can't be 1 or 2 because of Sudoku. So this is our 2. That's not a 2. And so these are consecutive. This is actually the smaller of the 2. So this can't be a 3. We can't add to 4. And so this must contain the 4 because they're consecutive, right? This sum is the same as this sum. This is contributing 1. This is contributing 2. So this is 1 less than this. And so it's either going to be 3, 4, or 4, 5, right? They're consecutive. So 4 is in one of those two. So that's not a 4. That's a 3, 5 pair, making this a 1. 1 plus 2 is 3. So all of our greens are 3. Perfect. That makes that a 5. And that tells us that this is 4 and 3. So now we know that that's a 5. Okay, let's do a bunch of Sudoku. That's 1, that's 2. Okay, that worked out. This 1 actually places a 4 there by our numbered rooms. That's 6, 3, and 5. This is our 5. 5 places a 1 there. Have we placed all of our 1s? I don't know. 1, 2, 3, 4, 5. There's one more 1. It's right there. Okay. This is a 4, 6. The 6 tells us the order. That's 4 and 6. This is a 2. Over here we get the 3. That's 2 and 3. This is a 5, 6 pair. This is a 4. This is 2, 4, 5. All right, that's not 2, that's not 4, that's not 2. Oh, the 2 goes there. I bet I have to do the numbered rooms at this point. That's probably easy. So these add to 5. So luckily with an odd number, we don't have to worry about repeating digits. So it's either going to be 1, 4 or 2, 3. So 1, 2, 3, 4. So they aren't, sorry, they could be 3. This just, I think Sudoku Pad's telling us it's not, but we're not going to use that. So we're looking at this area here, and we're placing a 3 and a 4. No, sorry, the 3 and the 4. We're looking at this digit. I got that backwards. We're looking at this digit and this digit. So this 4 places the 1. This has to be 1. That means this is 4. And that means in the third spot, we're putting a 4, and that resolves this 4, 5 nastiness. Okay. There we go. Okay, that was pretty straightforward. So actually, I think what happened here is Sudoku Pad said, well, in this row, in the solution, there aren't repeats, so I can do a non-repeat conflict check. But in this column, there are repeats, so I can't do a non-repeat conflict check. I think that's probably its logic. Unfortunately, that did give away that we don't repeat digits in the top row, but I mean, we didn't use that. We didn't have to. I certainly wouldn't want to. All right. Cool. Well, that was a neat puzzle, ChinStrap. I enjoyed that. Nice use of the numbered rooms with the region sums. I love region sums, especially outside the grid region sums. That's really neat. All right. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.